Okay. So coming to this, how Spark got evolved, the history behind its evolution. So just before even the Hadoop got introduced, came into the market. So the first time when our enterprise organizations were not able to solve the large data or huge data, so they came up with the first level of distributed systems. When you can't store and process the data in one single machine or server, they maintained a distributed fashion processing. And that first level of distributed systems that came into the IT industry, or like some of the RDBMSs like Teradata and Netezza, and this Teradata can process up to terabytes of information, and Netezza is also from IBM, which is a special separate box coming with hardware box coming with the software installed on it. These are also on the same notion of distributed systems, but they are scalable up to certain limits. Beyond that, they are like not able to scale. So that's the main problem. And second one is they are proprietary and they charge lots and lots of millions of dollars for annual renewals. Okay. And second generation distributed systems are like, if you talk about the Hadoop and NoSQL databases, we can consider into that. So these are open source, so cost saving. They can run on commodity hardware also, and they can scale up to some terabytes, even petabytes as well. But the problem is they are mainly batch oriented, and the latency is relatively high. The response time is relatively high. That is why we always start avoiding MapReduce because of its slow responsiveness. And coming to third generation distributed systems to avoid this performance issues. So we have one of them is like Spark, and there are few other tools which are in incubating status, Apache Flink or few other Apache Ignite, and these things, they all get the fast speed just because of exploiting the RAM memory, the main memory of your servers as much as possible. Like instead of reading the files from the disk, from the hard disk directly, they load entire data into RAM memory, and from there onwards it starts reading that. So relatively, reading anything from main memory or RAM memory is much faster than reading from the HDFS disk, or reading from your hard disk, or reading from your HDFS storage. HDFS storage is nothing but the disk storage only, because that gets distributed onto all the different data nodes. So
Shiva, can I interrupt you? Like, can I ask you a question?
Yes.
Now or like?
No problem. Yep.
So when we're like talking about second generation and third generation computers, the reason why we moved to second generation computers is like the first thing is like cost, right?
Yes.
Because of Netezza appliances, they are like really expensive.
And second one is scalability.
Scalability, right?
Yep.
So when we are like talking about third generation distributed systems, then we are again like bringing the concept of high memory, right?
Correct.
So again, they eliminate the concept of commodity hardware, right? So I mean, you have to like
commodity hardware in second generation. It's just a theoretical point. In my opinion, it's no longer a feature for Hadoop or something. You can run it, but how much value you will get when you run it on a commodity hardware? Even if you see the Cloudera or Hortonworks, the typical the data node configurations they suggest you is minimum 256 GB RAMs and at least 24 core CPUs, multi-threaded CPUs, and 100 Mbps IO channels, and at least 10 to 12 TB hard disks to type to them. They are not commodity hardwares anymore. They are like a huge servers only. Of course, I mean, if that is the question, like you can use the same commodity hardware for Spark as well. Here, how much ever the RAM memory you will get here, the same RAM memory will get used by this, but you will get only up to a limited speed.
So it's like a trade-off between the memory and
Correct.
the processing, right?
Correct. So, so day by day in the market or in the industry, so RAM is not that much costlier in the early or the pre-2000 years. Okay. So these days RAM is getting cheaper. So that's why trying to exploit that as much as possible. That is the notion.
Right.
So obviously, when you are dealing with GBs and terabytes of information, reading it from the disk slows down your performance. So the next option, the only option is reading it from the RAM. So based on that concept only, all these tools came up like, so Spark you can see, and Apache Flink is there, and Apache Ignite is there. So all these things, their main concept or the main funda behind these tools are like loading the data into RAM. That is how they achieve the speeds. Okay, it's just a trade-off, correct? So if you need speed, you need to go for high RAM memories. Okay.
Shiva,
Yes.
what is the industry standard? Suppose when you say that, you know, like what is the industry standard for RAM? You can say that it's like scalable, right? You can have n number of units connected, and so what is the standard approximately? Like, is it 8 GB or 16 GB or something should be there, right?
Yeah, the industry standard. Yeah, industry standard is 256 GB RAM machines. Okay.
Okay.
256 GB. I mean, even whether you are using Spark or not, still the Cloudera's standard recommendation, or even from the Hortonworks, the standard hardware recommendation from both of these things, if you refer any of the documentation sites also, because we do involve into the Cloudera meetings most of the times. Their strong recommendations is to use at least 24 GB, 256 GB RAMs and 24 core CPUs, multi-threaded CPUs.
For our system or only for a couple of it? There might be n number of...
No, n number of machines, it's the same.
Okay, thank you.
Okay.
Thank you, Shiva.
So hardware is dependent on our requirements. So we can decide how much memory, how much storage capacity that we need. Generally, we go from around 8 to 20 TB or 22 TB ranges of storage hard disk capacity for this CPU and RAM configurations combination. This is the most standard the hardware. Even if you see a small enterprise organization which is planning a 10 node cluster, even with that, if you see the real-time configuration, you'll find these figures, not less than these. So I worked on Hadoop clusters. So when it was around like 64 GB RAM for data nodes and 128 GB RAM for master machines. For one of our clients 3 years back, almost like it was their cluster was built around 2011 or so. So that time itself, this 64 GB RAMs and 128 GB RAMs they planned. So these days, from last 1-2 years, even if you have a 10 node cluster on your client, so that will be at least with this configuration. Okay.
What is the RAM on the master node for this? So it's the same.
It's the same. It's the same. No, here these days we don't need, since anyway data nodes also, like we are giving so much of RAM memory, so that much RAM memory is sufficient for your master as well.
So because most of the work is done on the node, right?
Master node is like a kind of indexing stuff. So this 256 GB RAM is sufficient for them.
Okay.
It's more than enough, I can say. Okay. Yeah, sometime when we get into any discussions, we can talk about like how does these resource allocations will happen. Anyway, this is not a job of your developer role or something. It's purely an admin's and infrastructure team's responsibility to distribute the resources, the cluster resources on each of the your Hadoop ecosystem tools, including Yarn, Spark, or Hive, Impala, or whatever. We can discuss sometime later when it comes in. But this is not hard stopping. Okay. Yeah. So with these third generation distributed systems, so they started using the RAM memory as much as possible, and they can work on multiple core systems on the same machine, and they can very well integrate with the HDFS for storage purposes, and they can run on any of the distribution processing frameworks. It could be either Apache Mesos or Yarn, and in real time you will see mostly 99% of the cases it's Yarn only. It's Yarn integrated because so Hadoop got evolved first. In any enterprise, Hadoop cluster might already be set up. On top of that, they plan to upgrade their clusters to Spark as well. Then obviously the option they will go with is Yarn only, because they already have a HDFS, Yarn, and Hive, Pig, everything set up. So on top of Yarn, they will go for Spark to the resource management of your Spark. Okay, we'll discuss a lot about that, Spark with Yarn integration. Okay, so now coming to the Spark. So what is it, and how is it similar to your Hadoop ecosystem tools, whatever so far you know? So we'll discuss them. Okay. So Apache Spark is something similar to your Hadoop. It is also an open source, and it is also a parallel data processing framework. But the difference is it uses in-memory cluster computing, which can access faster than disk access. That's the only difference. And Spark is fast, and it's like a MapReduce, like a processing engine. It's also one of the processing framework or processing engine you can call. It improves efficiency when compared to other processing algorithms like MapReduce, mainly in-memory computing primitives and any other general computations or computation graphs as well. So Spark first time initially started at AMP Labs, which is now changed to Databricks company. So few guys from AMP Labs came out and they started the Databricks. That is from where the Spark got released, the initial releases from Spark. It is not from Hortonworks, it is not from Cloudera. So sometimes people will get confused that since Cloudera is giving or something. So the way your HDFS, MapReduce, Pig, and HBase, all these things came from Yahoo, right? They got first time initially released from Yahoo, and they got contributed to ASF, Apache Software Foundation, open source community. From there onwards, everyone took them and they built their own flavors. It could be either Cloudera, it could be IBM Big Insights, it could be Hortonworks or whatever. Similarly, Spark came from Databricks. From there, it got contributed to ASF, Apache Software Foundation. From there, everyone took and got merged into their Hadoop distributions. Their own version of distributions, I can say. Okay, so it's coming to its history. It started as a research project at the UC Berkeley Amp Labs in around 2009, and first time it was open sourced in early 2010, and then after being released, Spark grew a developer community on GitHub. So it was released on GitHub and entered into Apache ASF around 2013. So Apache became a top level project only in the early 2014. So that's where once any tool becomes top level project, then only it is recommended to start using that for your real-time uses. Okay, so until then, if it is in alpha or beta releases or incubating phases, it's never suggested to, it's not recommended to use it for. You can do some POCs, up to POC is fine, but using it for real use cases, no one guarantees if something goes down. Okay, you'll not get any enterprise support as well. Okay, so I can say at least from starting from the mid of 2014, people started or enterprises started using Spark. Okay, almost like 2 years now. So at present, major contribution to Spark is from Databricks, and the code base size in Spark is just 20,000 lines of code. So when it was around 1.2 or 1.3 releases of Spark. This is just purely because of Spark is written in Scala, and Scala is so concise. You don't need that many lots and lots of lines of code. In Hadoop, just 1.0 release itself is having so almost 90,000 lines of code. It was written in Java. It is, okay.